Alright, today we're going to look at all of the options that we have for calculating delta H. So what we're looking at is calculating delta H, and we have a couple of ways we've discussed. We have Hess's law, we have heat and Stoich, and the third way is going to be using heats of formation. Heats of formation is basically the amount of energy that is absorbed or released from 1 mole of a substance is made from its element. The symbol for that is delta H sub F. So let's look at a couple of examples. And let's say in equation 1 here we have hydrogen plus 1/2 O2 yields H2O. We're going to make the hydrogen and the oxygen both gas. So what you'll see below me here is a reference table called thermodynamic data, and we're going to go down and look up the values for each of these. So for example, you're looking for hydrogen gas. Here you'll find hydrogen gas on the table. It takes 0 kilojoules of energy for that formation. And then we're looking for O2. Okay, so if I go to the table here, they're in alphabetical order. We're going to scroll down a little bit here, and we're going to look for oxygen. Here it is. Here's oxygen, which also has 0 kilojoules per mole. And the last thing we're looking for here is water. Okay. So let's go down here and find water. Here we go. Here is water. And remember, there are 2 different variations for water here. There's gas and liquid, so make sure you get the correct one. We want liquid, so it's a negative 286 joules. Kilojoules, I'm sorry, negative 286 kilojoules. All right, the next step here in our work is then to find heats of formation, or let's find delta H. Remember, delta H is heat of the products minus heat of the reactants. So what we have here are our products. If you add all of our products up, we have a negative 286 kilojoules. And we're going to subtract from that 0 kilojoules. So delta H for this reaction is a negative 286 kilojoules. All right, if we continue with another example, let me erase some of this. All right, if we continue to a second example, let me slide up here where I have some more room on my screen. Let's go ahead and let's look at what if you have methane gas that combines with 2 oxygen gas to produce 2 liquid waters and a carbon dioxide gas. All right, we're going to slide down in our thermodynamic data chart here, and we're going to look up the value for methane. So if we scroll down here in our chart, let's see, we have methane. Here we go. Here's methane, CH4 gas, negative 75 kilojoules. So let's get back up here to our work. And we have negative 75 kilojoules. We have oxygen, which we had in our previous example, which took 0 kilojoules. And we have 2 oxygens. And in our product side here, we have 2 of liquid waters. If you remember from the previous example, we found liquid water to be a negative 286 kilojoules. And remember, you have 2 waters. And then we also have CO2, which we need to look up in our table. So let's go down and find CO2. Alrighty, CO2, we're looking for CO2 gas. Here we go. It's negative 393 and a half. So go back up to our work here. We have some room. And we're going to go ahead and add 393 and a half, and it's a negative kilojoules. All right, we are back to where we were before, so we're going to calculate delta H, which is the heat of the products minus heat of the reactants. So we go to plug this in, we have 2 times a negative 286 kilojoules plus a negative 393 and a half. And from that, you're going to subtract a minus 75 kilojoules because it's minus the reactants. So what you get when you finish, punch that into your calculator, you're going to have negative 890.5 kilojoules. Remember, this negative value here tells you that this is an exothermic reaction due to the fact that delta H is a negative value.